So now let's look at some examples that involve even powers of trigonometric functions. In this case, we'll be using these double or half angle identities. So the sine squared of x is 1/2 times 1 minus cosine of 2x, so twice that angle. And cosine squared x is 1/2 times 1 plus cosine of 2x. So what we're going to do here, since integration by substitution is not going to help us, is apply this angle identity to sine squared of 5x. So sine squared of x is 1/2 times 1 minus cosine of 2x, which means that sine squared of 5x will be 1/2 times 1 minus cosine of 10x. So let's make that substitution here. So basically, instead of writing sine squared of 5x, we're going to replace that with 1/2 times 1 minus cosine of 10x. And now, before we integrate, let's clean this up a little bit. Let's pull this factor of 2 out front. So we'll have 2 times the integral of 1 minus cosine of 10x. And now, let's just integrate, and let's try to do this without doing a formal substitution. So the integral of 1 with respect to x is just x, and the integral of minus cosine of 10x, well, we think it would be sine of 10x minus, and so if we take the derivative of this, we'll get cosine of 10x. But we're going to have an extra factor of 10 if we take the derivative by the chain rule. So we multiply by 1/10, and then we have our constant of integration. So our final answer, if we clean it up a little bit, will be 2 times x minus sine of 10x over 10 plus a constant of integration. Next, let's look at a problem where we have an even power of cosine, which is larger than 2. So what do? What we do is we're going to think about this as cosine squared of 3x squared. And now we're going to apply our angle identity to the cosine squared of 3x there. So if cosine squared of x is 1/2 times 1 plus cosine of 2x, then cosine squared of 3x will equal 1/2 times 1 plus cosine of 6x. So now let's rewrite that, putting this here. So what we're going to be integrating is 1/2 times 1 plus cosine of 6x, all of that squared dx. So now, how do we integrate this? Well, what we're going to do is pull this 1/2 squared, which will be 1/4 out front, and then we'll be integrating 1 plus cosine of 6x squared dx. And now we're just going to rewrite this by multiplying 1 plus cosine of 6x times 1 plus cosine of 6x, and we'll have 1/4 times the integral of 1 plus 2 times cosine of 6x plus cosine squared of 6x. So now this is what we're integrating. And now let's look at the problem. This is something we can integrate. This is something we can integrate fairly easily. But now, what have we done? Well, now we have a squared cosine here. So we're going to apply the angle identity again to that part. So we have 1/4 times the integral of 1 plus 2 cosine of 6x plus, and we replace cosine squared of 6x with 1/2 times 1 plus cosine of 12x. And now we're almost ready to integrate. What we want to do here is distribute the 1/2 before we actually do the integration. So now let's see what happens. Well, we have the 1/4 out front, Here we're going to have a 1/2. If we distribute the 1/2 times 1, well, here we have a 1, so we can combine those two terms to have a 1.5 or 3/2. Plus, we have our 2 cosine of 6x. And then if we distribute this 1/2 here, we'll have plus 1/2 cosine of 12x. And now we're finally ready to integrate. So this will be 1/4 times 3/2 x plus, now how do we integrate cosine of 6x times 2? We'll have 2 times 1/6 sine of 6x, just doing a quick substitution in our heads. And here we're going to have a plus 1/2 times 1/12 sine of 12x plus our constant of integration.